Good day, great of learners. I'm back with mechanics. This time we are going to look at frictional force and their types and how they behave. We're going to look at types of frictional forces that are very useful in understanding Newton's laws as well as work, energy, and power. Frictional force is defined as the force that opposes the motion of an object which acts parallel to the surface. There are two types of frictional forces. The first one is static frictional force, which is defined as the force that opposes the tendency of motion of a stationary object relative to a surface. Please note that in every definition, there are keywords that you are supposed to include when defining a particular term or concept. So, if you omit those keywords, you lose marks during examinations. Please take note of those keywords. In these two definitions, those keywords are underlined. So take note of those keywords. And you must define those terms the way they're defined on the board. In symbols, static frictional force is given if S max is less than or equal to mu S times N, where N is the normal force. If you remember, I emphasized in the previous lesson that the normal force is very key for calculation of frictional forces. There are three important things that you must take note of about frictional forces and the way they behave when you apply other forces to an object. If a force F is applied to an object parallel to the surface and that force does not cause the object to move, it means that F, the applied force, is equal in magnitude to the static frictional force. Number two, static frictional force is maximum just before the object starts to move across the surface. And finally, if the applied force exceeds Fs max, it means a resultant or net force is going to accelerate the object. In other words, there is going to be a resultant force that will cause the object to accelerate or to move at a certain velocity. The second type of frictional force is kinetic frictional force. Please remember that kinetic frictional force is only available when an object is in motion, not an object that is stationary, not an object that is at rest. So, kinetic friction force is the force that opposes the motion of a moving object relative to a surface. Again, the reminder is take note of the underlined words because they are important for in the definition of kinetic frictional force. And in symbols, Fk equals mu k times N. And also note that from the first equation and the second equation, we can see that the magnitude of frictional force depends on the normal force. If you look at those two formulas, Fs max is less than or equal to Fs times N and Fk equals mu k times N. It means frictional force depends on N. If N changes, then frictional force is also going to change in magnitude, and the change is in proportion. If normal force increases, it means frictional force is also going to increase. If the normal force decreases, then the frictional force is also going to decrease. That's what it means to change proportionally. There are certain characteristics of friction force that you need to be aware of. The first one is that friction force is proportional or directly proportional to the normal force. And this is directly coming from the two formulas that we have just looked at. The second characteristic is that frictional force is independent of the area of contact. So it doesn't matter whether the area of contact is large or small, frictional force is going to have the same magnitude. Whether the contact area is small or the contact area is big, frictional force is going to remain the same in magnitude, regardless of that contact between the object and the surface. The third characteristic is that friction force is independent of velocity of motion. So if an object is moving slow, frictional force will be the same as the same object moving faster on the same type of surface. And also remember, frictional force opposes motion and it acts parallel or relative to the surface. And remember, frictional force is a contact force. It only works by touching, it only works by getting in contact with an object and a surface. That's all for now as far as frictional forces are concerned. That was just a reminder. And in the next lesson, we are going to look at problem solving using the normal force that we have been emphasizing, as well as using frictional forces and all the types of frictional forces that we have just mentioned in this lesson. Otherwise, for now, that is all. Let's meet in the next lesson. Thank you and bye-bye.